Oh, please.
Yep, start it.
Okay, perfect. Thank you, everybody, for attending our November webinar. This semester is flying, so I am very glad that you were able to attend tonight. I am really excited to introduce our guest speaker, Dr. Josh Gray from the Coast Guard Academy. I have known him now for a couple years. In my non-Penn State capacity, I work as a contractor at Coast Guard headquarters. And a few years back, I'm in the Office of Specialized Capabilities on the Countering Weapons of Mass Destruction team. And a few years back, we wanted to introduce CBRN, Chem Bio Rad Nuke training at the Coast Guard Academy, like the other service academies had. So we reached out to the leadership there, and they were very supportive. And we were able to put together a training plan with our Special Mission Training Center and Dr. Gray from the Academy. He was a great advocate up there and also logistical support up there. So once a year, we go up there, and all of the seniors who are graduating, the first class cadets, the week before they graduate, it's called Ensign Transition Week, and they undergo a online training, and then the week when we're up there, they undergo a practical training session where they're putting suits and masks on and off, and they're getting the hands-on experience. So when they leave the Coast Guard Academy, they have their qualification as they report to their new unit. So as I said, Josh has been a great help with this initiative, and he's been great getting to know him over the past few years and chatting about some of these things. And he is a chemist by trade. And one of the things that we do talk about a little bit in 410 is the CWC and chemical weapons. So I invited him to come speak tonight and go more in depth than we are able to. I know we have a lot of interest in it, we just don't have the time. So I'm going to turn it over to you, Josh, and thank you so much for speaking with us tonight.
Thanks, Jen, and thanks for the invitation to speak. I'm happy to do so. Let me just quickly state this disclaimer that I'm a professor at the Coast Guard Academy, and the opinions I present here are my own and not those of the Coast Guard or the Department of Homeland Security necessarily. So this is just my opinion. So just to give you a little background of who I am and where I'm from, I went to Penn State. I graduated with a BS in biochemistry, molecular biology in 1998, and then I got my PhD there in pathobiology in 2004. So go Penn State. And then I went on to Rutgers, where I worked for 4 years, first as a postdoctoral fellow and then as a research assistant professor in a toxicology lab. And as I'll get to in a second, one of the things we ended up working on there was mustard gas therapies. From 2006 onward, I started teaching online for the University of Maryland Global Campus. And I started teaching a course called Agents of Bioterrorism. And I teach a second course there as well. And since 2008, I've been at the U.S. Coast Guard Academy. I am in the chemistry department, but I'm not really a chemist, I'm more of a biochemist. So these are the courses that I've actually taught. So since 2007, I've been teaching this Agents of Bioterrorism course. And there's also an upper level course I teach called Strategies for Interagency Cooperation, Verification, and Global Countermeasures in Biodefense. And at the Coast Guard Academy, I've taught Science of Terrorism. When I was at Rutgers, I studied molecular mechanisms of how vesicants work. Vesicants are blistering agents. And for a short time afterwards, I worked on that as well. And then I've written a bunch of book chapters on sulfur mustard, which is mustard gas, since that time. So what I'm going to talk about today is the history of chemical weapons, how we got about using them, where they came from, and when they became they became the big thing that they are today. What happened during World War II. And then I'll cover a little bit of the post-World War II uses of chemical weapons. And then I want to talk about the Strategic National Stockpile, which is where public health comes in, and the building of the biodefense strategy since the anthrax letters of 2001. So a lot of the lecture comes from this great, great book. I know no one has time to read that well, but I can't speak highly enough of this history that Jonathan Tucker wrote. Jonathan Tucker has since passed away. But he has this great story about how chemical warfare happened from World War I all the way to Al Qaeda. And there's a really nice NPR interview with him. It's on at that hyperlink. It's about 45 minutes long. So if you get a chance while you're at the gym or something like that, listen to it while you're doing that. It's really great, and it just gives you a whole history. But I'm going to give you a piece of what he talks about in there. So when we talk about chemical weapons, we think about, we think about things that are poisons, but it does also include things like smoke, like flammable material, things like gases, and actually toxins are considered chemical weapons as well. Toxins are poisonous materials derived from living organisms. So it could be like anthrax toxin or botulinum toxin or ricin or something like that. So they're considered chemicals because they're not alive and they don't replicate. So unlike an infectious agent where it can spread from person to person, chemical exposures are pretty much you get exposed, you might off gas it to someone else who's a rescuer or something like that. But so chemical weapons aren't really new, of course. We've known about things like poison arrows, smoke. Spartans used wood, pitch, and sulfur under the walls to try to incapacitate their enemy. There's been poisonings of like rivers going into cities, things like that. These things have been going on for a long time. And then with as warfare got more and more developed, people started to try to incorporate things with explosives. So belladonna grenades to produce toxic fumes, perhaps. In 1854, Lyon Playfair developed a cacodyle cyanide artillery shell. The idea was rejected as being dishonorable, as such as poisoning the wells of the enemy. So back in this time, as you will remember, people used to line up on the battlefield and shoot at each other in these straight lines. So there was a lot of honor in warfare that was considered to be important. Even in the Civil War, there were people on both sides of that who proposed using things like chlorine gas or to use poison gas from balloons and things like that. So the ideas were out there for a long time, but they just weren't very effective and they weren't widely adopted. And so when you think about chemical weapons, it was sort of foreseen a little bit in the Hague Conference of 1899. This was one of the first, if you want to think about the Geneva Conventions, this is one of the first ones. And one of the things, they banned three things at this convention. They agreed that these things were dishonorable and they shouldn't happen. One of them was launching projectiles and explosives from balloons. The second one was preventing the use of projectiles with asphyxiating or deleterious gases, so chemical weapons. And the third one was the use of projectiles which explode or flatten easily in the body, otherwise known as hollow point bullets. So those are the three things that were banned in that treaty. And it's really interesting that two of those three things are now considered okay. So it's kind of interesting how people's ideas about these things change over time. So why have the other ones been deemed acceptable and why have chemical weapons remained banned is pretty interesting. So I'm going to show you, you have to forgive me on this talk because it does have a large number of slides, but a lot of them are pictures and quotes and things like that, which are kind of interesting. So this was a Lyon Playfair, who I mentioned, a British chemist from 1854, and he was arguing that no doubt in time, chemistry will be used to lessen the suffering of combatants and even of criminals condemned to death. And indeed, we now use chemicals to put people to death in some cases. So a lethal injection, if you will. But the thought was at this time was maybe using chemistry for warfare is actually going to be more ethical because if you kill someone without pain, perhaps maybe it will end the war faster or it will be a little bit more honorable, not less honorable. So that was some of the arguments that were made. Interestingly, the U.S. refused to sign that original Hague Conference, and he argued the inventiveness of Americans should not be restricted in the development of new weapons, and the U.S. wouldn't sign that treaty all the way until 1975. So the U.S. actually maintained the ability to use chemicals all the way until that time. It wasn't until President Nixon that the U.S. decided it was going to get out of the chemical weapon and biological weapon business. And do you have any idea why? What did he think would make us not need chemical or biological weapons? And if I had an audience, I would ask, but the answer is nuclear weapons. So sometimes biological and chemical weapons are called the poor countries' nuclear weapons because they kind of are, pretty horrible things that you don't want to unleash. But having them kind of is a way of mutual assured destruction. So in World War I, it was interesting because the Germans invaded, and then there was what was called the race to the sea, where the troops on both sides of the line dug in these trenches, and the trenches lasted for hundreds of miles all the way to the sea. And what ended up happening in this particular war that was interesting was there was a high pace of technological advances that outpaced the development of military tactics to overcome them. Primarily, defenses got a lot better. And because the defenses were much better than the offenses, this led to a stalemate where both sides were putting things like barbed wire, machine guns, and artillery, and they were preventing, you could get through those at great cost of life. They didn't have tanks, for which would happen in World War II, which could get around these things. So it caused a stalemate. And during that stalemate, people decided to try to come up with ideas for how to break through them. So various innovations were attempted of all kinds, trying to use a lethal curtain of steel, of artillery fire to stop, to kind of surround an area so that you could break through the line and they couldn't have reinforcements go through there. The French ended up trying to use these ethyl bromoacetate grenades. This chemical is what's called a lacrimatory agent. It causes a tear gas type of agent. So, and these grenades have been successfully used previously on a ring of Paris bank thieves, but they were ineffective on the battlefield because the fumes just diffused so quickly outside that they didn't work. And they tried them, they didn't work, and they stopped using them. And that kind of idea happened over and over again. Now, during this time, there was also fear that both the other side was going to use chemical weapons. And in fact, turbinite is a fake or a fictional explosive gas that gives off lethal fumes. Germany suspected that they had a number of asphyxiations that were caused by this chemical, but really they were caused by carbon monoxide. And survivors of the turbinite barrage thought they probably smelled explosive fumes. So I mentioned the chloracetone was another one that they tried to use for cartridges and grenades. And they were thinking about doing that. The Germans captured it. So the Germans thought, well, they're using chemical weapons. We should be able to use chemical weapons. And that was where things started to go down. Another chemical that was attempted was October 27th. This was used on the British at Germany. Completely ineffective. No one even knew they were exposed. So now, if you go back and look at the Hague Conference, the contracting powers agree to abstain from the use of projectiles, the sole object of which is the diffusion of asphyxiating or deleterious gases. You can overcome this if you think about it. You just say, well, let's not make projectiles with that sole purpose. Maybe they have a dual purpose. And then you can get around the spirit of the law. So they invented this T shell, which has it's a shell with an explosive component, and it has two compartments. One is gas, one's explosive, and it kind of evades the spirit of the treaty. So the Germans end up using that T shell with an explosive charge. They figured out how to stabilize it, and they launched it at the Russians in January 31st, 1915. And if you were a chemist, you would know that this chemical does not vaporize at that temperature in the wintertime in Russia. So of course, once again, didn't work. So that leads us, so it's not that they, both sides were thinking about using chemical weapons, and they tried to use it, but they just didn't have the chemical knowledge, perhaps, to get it to work. Then comes along Fritz Haber. Fritz Haber he won the Nobel Prize in 1918 for developing the Haber process for fixing nitrogen from the atmosphere. And that is basically the process by which you can use it for fertilizer, which is why he won the Nobel Prize. But of course, nitrogen is a major component in explosives, TNT, right? So this process basically gave an unlimited amount of nitrogen, which could be used for both processes. So Haber's a chemist. He's a nationalist. He loves his country, and he wants to think about ways that he can, help his country in warfare. And one of the ideas he had was to use chlorine gas. So the idea was that these are cylinders that deliver gas that would not violate the Hague ban. They're not projectiles. So remember, the treaty said you couldn't use projectiles. Well, these are not projectiles. Chlorine was immediately available widely, non-persistent, and volatile. So they accumulated a bunch of these, and by 1915 in March, they had 1,600 of these cylinders and 168 tons of chlorine. And what they did was they put them right in the middle of their trenches, and they had these tubes leading out of the pipes, out of the cylinders, pointing at the enemy. So the idea was they would blow this gas over the field, and it would get to the enemy, and then they just had to wait for the weather to be the right conditions. So this is an account of what happened. They ended up using it, and British and Canadian troops looked into the haze and to their amazement saw soldiers, many without weapons, emerge from the cloud, running wildly and in confusion. Terror-stricken Algerians, coughing and clutching their throats. French soldiers staggered by, blinded, coughing, chests heaving, faces an ugly purple color. And then the artillery stopped, and the Germans advanced, and they took some land, and they ended up moving the boundary of where the land was. They got a new front line out of it. But this was really, I would argue, the first event of chemical weapons use in the modern age. And so after that happened, the effects of chlorine, how does it work? Basically, it smells like a mixture of pepper and pineapple. It's got a metallic taste. And the reaction it does in water is if you mix chlorine with water, it forms 4 hydrochloric acids for every 2 chlorine molecules, and it off gases O2. HCl, needless to say, hydrochloric acid is terrible. So the good news is the Allied troops figured out a way to adapt. The Germans used chlorine 4 more times through May, but the advantage was lost. People figured out how to make protective masks. You can even make a mask with a damp cloth soaked in urine or water and put it over your face. And what will happen is the chlorine will produce the HCl inside of the cloth and not get into your lung. And they also realized that since chlorine is denser than air, when this happens, you stand up on the fire step, which is where you stand up to shoot, and you're going to be less exposed to the chlorine gas. So, of course, right after this happened, the French and the British retaliated with their own capacity. They tried to use it as well. And so other gases that were used was tear gas. Believe it or not, tear gas is still banned in warfare by the Geneva Convention. You cannot use tear gas. And you might think, well, that's funny. They use tear gas all the time. You are allowed to use it against your own citizens. You just can't use it in warfare. Isn't that weird? Well, anyway. So they figured out that tear gas was good because if you gave tear gas in combination with chlorine gas, the tear gas would cause you to rip off your mask and then you'd be exposed to the other gases around. So, but the king of the war gases is mustard gas. And you can tell it's a very simple chemical structure. It was discovered as early as 1822, and the toxic properties were published in 1860. In 1913, there was a person who was mixing 2 chemicals in the lab. A flask broke. He was hospitalized with burns for 2 months. They reported the findings to the German Chemical Society, and it turns out that the chemical that was in this process, 2-chloroethanol, was widely used in the German dye industry. So because of that, it was widely available. The German government was looking for possible chemical weapons, and they asked them to provide them. So mustard gas really became a very important weapon. It's not really a gas, it's a liquid, but because it has a high vapor pressure, it can off gas. And so even if you're around it in the lab, its off gassing will get onto your skin and in your eyes and whatever else, and you'll be exposed to it that way at a reasonable temperature. If it's really cold, you'll be fine, but room temperature, you'll be exposed. So this one is actually pretty insidious because mustard gas doesn't take effect for some number of hours after exposure. You get exposed, you have no idea. You might sense a small garlic odor, but largely, even if you pour liquid onto your skin, you don't even feel it. And so, but the problem is it causes, if it gets in your eye, it can cause blindness. It tends to get the very moist parts of your body, so your crotch area, other areas that are very unpleasant, and armpits, anything that's moist, it will react with. And so it's pretty bad. And it's particularly bad because it causes a lot of injuries. And if you think about the cost to morale, having your fellow soldier get injured and then they're blinded and they're taken off the battlefield and then they have to get treatment, it's a very costly agent. It doesn't necessarily cause a lot of death, but for the people who are exposed via the lung, they can get lung infections as a result. And remember, this was pre-antibiotics. So that was like a death sentence in some ways. This is actually a more modern exposure. So I'm going to show you some gross pictures, bear with me. But there's been a number of exposures that have happened since World War I. Obviously, we don't make it anymore. We don't use it, but it's been used in a number of wars. This is actually interesting. So after World War One and World War Two, they took all the armaments and they dumped them in the ocean. Well, mustard gas can survive at the bottom of the ocean in these old artillery shells. And what happened in this one case was somebody gets an order of shells delivered to their driveway, like seashells, but inside of that order is actually an old artillery shell. Picks it up, puts it on his shoulder. Little bits of liquid drip out, doesn't even know they're exposed. And then they have like this nasty injury you can see from it. So it causes these very large blisters that are very painful. And for whatever reason, the healing process takes a very long time to treat, to get better. So this is the chemical that I worked on at Rutgers for a number of years. We didn't work on the actual chemical. We worked on a very similar molecule, but because you can't work on the actual chemical weapon, that's part of the treaty, unless you use more than a very small amount of it. But needless to say, Rutgers was not going to let us make mustard gas and use it in the laboratory. So some labs do though. You can treat it with a little bit of hot soapy water if you do it in time. You can also use this chemical that's like Vaseline to help block exposure to it, but it's very uncomfortable. Putting Vaseline on your body all over works, but it's not a great way to eliminate exposure. So this is a list of, just to give you an idea of all the things they tried. These are all the chemicals that were used in World War I. Phosgene is a big one, which is also an industrial chemical. Many of these you probably never heard of, and I haven't even studied since I looked at this list. Here's some more. Mustard gas is at the top of this list, but other things like tearing agents, things like that. So the lessons learned at the end of World War I, as I finish up part one here, General Pershing, who was one of the major generals at that time, he said, whether or not gas will be employed in future wars is a matter of conjecture, but the effect is so deadly to the unprepared that we can never afford to neglect the question. So this basically started the Army's Chemical Corps, and which still exists to this day. And it's meant to provide the Army with, we have all signed this treaty, but we're not going to trust that people are really going to adhere to it. So our U.S. soldiers need to make sure that they are trained in potential exposures to chemical weapons, and that's exactly, and biological as well. And that's exactly what Jen was talking about earlier today. She comes to the Coast Guard Academy every year, and they train all of our students in how to wear the gear that protects you from exposure to these things. So some of the lessons learned from World War I are that, there was a lot of deaths on the battlefield. Of those wounded, 70,000 of the 225,000 were from gas wounds. And of those, 1,200 died in the wards, but a lot of people were permanently injured from these things. And importantly, soldiers exposed to chemical agents would remember their effect in later wars. In fact, Adolf Hitler himself was blinded by a British gas attack. And that is an interesting prelude to our next part. So I'll take a pause there. Any comments or questions for part one? All right. Hopefully this is interesting and you're learning things. So.
Oh, this is so interesting. Thank you. Proceed.
It is. This
Thanks.
is great.
Thanks, Chelsea. Thank you, Jen. All right. So next I'm going to talk about nerve agents. So, in between World War I and World War II, the Germans had to pay reparations. And what ended up happening was the Germans lost a large amount of their land that was taken by the Allies and by Russia. And they also had to pay a very large amount of money. This caused them to become very embittered, and but also to try to use their inventiveness to try to overcome things. So one of the things they needed to do was make sure they could grow enough crops to feed themselves. Having lost a significant portion of their farmland to Russia, they set about developing new insecticides that were going to be able to increase farm productivity. So they employed, there's a scientist named Gerhard Schrader who was employed by IG Farben, which is a subsidiary of Bayer aspirin, if you know what that is, of course. So he ran an insecticide laboratory, and he discovered some very effective insecticides, including parathion, which is interesting, still used. But he also invented this class of chemical called organophosphates. It interrupts the nervous system of insects, and that's how it works. But so as I mentioned, the Germans tried to become sufficient in this, So Otto Baer gave Schrader's group the task of developing a pesticide that would treat weevils in grain silos. So what he did was he first attempted fluorine-based compounds, but there were human side effects. So a good pesticide, if you think about it, it should be toxic to the insect, but not toxic to the human. You want to be able to even eat small amounts of it, ideally, right? You don't want to eat them. I'm just saying, if you treat the food, it's probably going to be on there. He also tried some sulfur-based compounds and some phosphorus-based compounds, and that actually had success. So he proceeded to patent the compound. Then he began to design structural variants of this to increase efficacy and decrease human toxicity. He knew cyanide was toxic, which then he included in the molecular structure, and he came about with this compound called tabin. So it's not, again, not a very difficult molecule. If you look at it, count the number of atoms, it's a handful, it's like 10 or so. So it's not a very big structure. But what he noticed was immediately upon synthesis of this in November 1936, he had some side effects. He had a headache, poor concentration, he experienced some shortness of breath, and a dimming of the visual field. He stopped being able to read, and he realized he had pinpoint pupils, which is a major symptom, by the way, of nerve agent. You ever see someone exposed to a chemical agent and they have pinpoint pupils? Run away. They're not going to live, and you need to run. So he had to spend 2 weeks in the hospital as symptoms worsened. So I just want to mention he didn't call it tabin. It was named later for that, but it became named that because tabin is short for taboo or taboo. That's kind of where that name came from. So he distilled the final product, and it ended up being a clear, colorless, tasteless, fruity odor, and it worked great on insects. 1 to 200,000 ratio killed all leaf lice on contact, but the human toxicity was significant. And the problem was once you were exposed once, your second exposure made you even more sensitive to it. So you couldn't end up working with it. So in May 1937, they began testing on animals. They injected apes with 100 micrograms, and this caused nausea, vomiting, pupil constriction, vomiting, drooling, and sweating, all these symptoms, and eventually paralysis of the breathing muscles, and it caused death. So I.G. Farben reported it to the War Office in 1935, that all patents and findings of military significance had to be reported. And from there, it went to the German Weapon Development Office, and Schrader was invited to Berlin to demonstrate how it works and how it was made. This ended up being produced at this gas protection laboratory with 300 workers. This patent was classified as top secret, and the Army asked Schrader to make a kilogram of it, and then he went back to work on pesticide compounds. Now, one of the problems was I.G. Farben didn't have the facilities in place to make a war gas, and they were all located in densely populated areas, which is a terrible idea. I'm not going to get into that, but needless to say, a number of workers were mistreated. Of course, they used slave labor in Germany. It went on to be some horrible ethical things happened, and I won't get into that today. But anyway, so because tabin was top secret, Germany had the luxury of developing countermeasures to it. They figured out they knew that atropine works the opposite way. They know pinpoint pupils. Atropine is the same thing they give you, or scopolamine. You might know what scopolamine is. You ever get those things you put on your back of your ear when you're trying to not get nauseous, and you touch your eye after that, it's going to go and make your pupil enormous. Or when you go to the eye doctor and they dilate your eyes. So it's the opposite of how nerve agent works, which is too much acetylcholine. Atropine is an inhibitor of acetylcholine signaling. So they had some treatments for this that would work. Now, would it be used? Hitler decided not to use it. They made a stockpile of it, but it's interesting that they didn't use it. Let me tell you why. So anyway, there were some problems with the plant. I'm just looking at the time here. So they were wondered, wow, this was really easy to make. Maybe the Allies have their own chemical weapons. Maybe we shouldn't use it because they'll retaliate with chemical weapons against us. And they had no reason to believe why not. If America, England, and Russia were all intensively studying chemicals themselves, maybe they had already invented another chemical weapon. And the answer is we weren't, but we did have a supply of chemical weapons. So, of course, the war gases were used internally. Zyklon B was used to assassinate Jews and other civilians in concentration camps, but there was no interest in using them in warfare, only as a matter of they had them in case they needed to use them. And of course, other problems happened as well. They were short phosphorus. They didn't have enough other things. So there were a lot of problems with Tabun itself. The workers kept dying from it, and they were using forced laborers. The people in the concentration camps were made to work in these factories. It was pretty terrible. So how does it work? So, you have an autonomic nervous system, and inside of that, there's the sympathetic side and the parasympathetic side, which is the brake. The parasympathetic side uses acetylcholine as a neurotransmitter. What happens is the neuron releases acetylcholine, it then binds to the receptor on the nerve cell, and it stimulates it to contract. You probably studied this in biochemistry. What nerve agents do, so what normally happens is when acetylcholine is released, there's an enzyme present in the neuromuscular junction that will degrade, it will destroy the acetylcholine pretty rapidly. So if you stop releasing acetylcholine, the net effect is it stops stimulating the muscle to contract almost instantly. What this nerve agent does is it inhibits acetylcholinesterase. It's what's called a suicide inhibitor. It inhibits the enzyme permanently. We don't use permanent inhibitors of almost any enzyme because that's not a good drug. So what ends up happening is if you get exposed to this, your body has to make more acetylcholinesterase for you to recover. So if you think back to what we said about being sensitized to it, what happens is you don't notice you're exposed until about half of your acetylcholinesterase is gone. And then it takes time for it to come all the way back. So what happened was when people are sensitized to it, maybe it drops down to about 30% of what it should be, you start experiencing symptoms. And if you try to recover for 2 weeks, maybe you go back up to 50% of what it would be, but it would take much longer to get to 100%. So that's kind of how this works. So, and what scopolamine does, or atropine, is it binds to the receptor for acetylcholine, but it doesn't activate it. So it's a temporary treatment, but not something that's going to make you survive in the long term. So the net effect of this agent is it's a paralytic. It causes you to contract all your muscles simultaneously, and you can't breathe because you can't inhale. So that's how it kills you. It's a terrible way to die. So so they worked out how that works. Other nerve agents have been invented since then, including sarin and soman. And the Allies, it turns out, had no idea that the Germans were doing this. They heard about this Blau gas numerous times. They ignored it. In 1943, they captured a German army officer who talked about it. They didn't have any evidence for it, so they didn't believe it. They speculate that Hitler's hesitation was the fear of retaliation and how it would hurt his own soldiers, and maybe it links back to his own experience of being exposed to chemical weapons, that he himself was like not willing to even go there. It seems crazy, one of the most notorious villains of all of the history was like, no, that's too far. So very interesting. So why did they use it? By the time there was enough synthesized, the US controlled the air. And even if the Allies couldn't retaliate with nerve agents, they did have massive stockpiles of mustard gas and phosgene. And so that's probably why they didn't use it. So anyway, how close did the Allies come to using chemical weapons? So there were some chemicals that were made, but it wasn't much more toxic than mustard or phosgene. So they just stopped making it. They decided, well, we got these other ones. We don't need this other one. So, and FDR said any use of gas by any Axis power will be immediately followed by the fullest possible retaliation upon munition centers, seaports, and other military installations through the whole extent of the territory as such Axis country. So there was this huge threat of retaliation. There was a thought of Allies using chemical weapons against the Japanese in the Pacific, but they feared that the US doing it there would cause the European countries to do it. So that ends kind of part 2. But before I fully end that, I want to talk about this really interesting incident that happened. So in Bari, Italy in 1943, there was the German bombers attacked American tankers and munition ships. some of those ships contained American-made mustard gas. And those 16 ships were sunk. Hundreds of sailors were forced into the water, and many of those sailors were exposed to mustard gas. Oil in the water coated, but a few mentioned a faint garlic smell. These soldiers experienced skin lesions, stinging eyes, and internal problems. 83 people died, and one of the ships contained what was called nitrogen mustard. The Italian doctors who looked at this figured out that the soldiers exposed to nitrogen mustard had immune suppression, similar to that induced by radiation. And they knew that immune suppression was used to treat certain cancers. So the hypothesis was, well, maybe nitrogen mustard can be used to treat cancers. And in fact, it still is today. So nitrogen mustard is a drug derived from a chemical weapon. How about that? Isn't that interesting? So mustard agents are chemotherapeutics. They cause you to get very sick. They work by doing alkylation. They attach to proteins, to DNA, and they kill rapidly dividing cells. Of course, when you're on a chemical like that and you're exposed to it, what happens? Your hair falls out, you lose your stomach lining, you get nauseous. So nitrogen mustards are still used today. And in fact, you can buy nitrogen mustard and use it in the lab. So we would use it as an analog for mustard gas and studying it. So yeah. But interestingly, to this day, there's no really good therapies for mustard gas. So unfortunately, I worked at Rutgers for years on this. The only way you can really treat it is by doing what's called dermal abridgment, where you cut off the layer of skin that would, so you have a massive blister, it's nasty. Surgically come in and even cut off even more tissue, right? And something must be remaining on the tissue that causes that wound to heal so slowly. Those people will do better. They have like pastes and stuff you can put on your skin that protect you from exposure, but not so much for treatment. And so it remains to this day something that's a problem. How do you treat mustard gas exposure? So anyway, VX was invented post World War II. It was invented by the British as another chemical weapon, and it was passed to Portondown in 1954, which is their major chemical weapons directorate is in Portondown. They traded VX to the US for nuclear secrets. So the US taught Britain how to make nuclear bombs, and Britain taught us how to make VX. What's interesting about VX is it's actually it's called a binary agent. It's two chemicals that by themselves are not toxic that you can mix together and then you produce VX. So it's safer than nerve agent in the sense that if you have these two chemicals separated, they're not going to cause toxicity. So what the Allies would do is they would make bombs that would like they're falling out of the plane, and as they're falling, the chemicals mix together. A chemical reaction happens, makes the toxic chemical, and then that's what's used to cause toxicity there. So after World War II, the Germans, a lot of the German scientists were captured and actually became part of the war programs. Our rocket industry, in fact, is the fact that we were first to the moon had a lot to do with capturing the German scientists and putting them to work. We also put to work the German scientists for chemical weapons. So this is a story about that, which we'll skip. I'm going to fast forward now to what I'm going to call part 3, and we're just going to quickly go through a couple other chemical agents. So while chemical weapons haven't really been used that much since World War II, and by major countries, they have been used quite a bit in other incidents. In fact, the three main ones are here: Egypt with mustard gas in Yemen, Iraq using chemical weapons in the Iran-Iraq War in the 1980s. And in fact, there's a huge number of papers, scientific papers written by Iranian scientists, even to this day, on the long-term effects of chemical weapon exposure, mustard gas exposure. So they're the leading world experts in what happens when people are exposed, because they're dealing with the aftermath of these people who are still alive today, who have been exposed to this agent. And then Syria used sarin against its own civilians in its civil war. They only stopped as a threat. There was a massive U.S. threat to basically destroy the country if they didn't agree to give up the chemical weapons, and they did. So, but Russia has continued to use chemical weapons and for assassinations. So, this is Sergei Skripal, a former Russian military officer and a double agent. he defected to the UK. He was poisoned with a chemical called Novichok. Interestingly, I wrote a paper a number of years ago. We were working on a journal with a colleague of mine about 10 years ago. We wrote we had a special issue of a journal looking at the rarer chemical weapons, the ones that have kind of been ignored. And we were like, just what's out there? Let's do a review article on all these different agents. And so one of the ones we wanted to cover was Novichok. And I worked with a reserve colonel, and he's like, if you work on that chemical, I can't be an editor on that. So basically, it was still classified at that time. He couldn't be associated with it because it was his way of telling me that. But since then, I think it's become declassified. I don't have a security clearance, so I can talk about anything. So that's why don't get a security clearance because then you have to, even if it's public, doesn't mean you can talk about it. So anyway, they figured out the suspects, and this is a really fascinating story if you have time to dig into it. Some internet sleuths saw their photos, went back through the Russian archives of graduates of this military college and showed that they were Russian agents, right? And so after this, of course, Russia denies it, but the Organization for the Prohibition of Chemical Weapons added all the Novichok chemicals to their banned list of chemical weapons since then. And so what do they look like? They kind of look very similar to sarin a little bit. They were developed by Russia. Some of them are more potent than VX. The argument is, do you really need a more potent chemical weapon than VX? I mean, it's already ridiculously toxic. So like, if 50 nanograms will kill you, do you really need an agent that's 10 nanograms? Like I think that's some of the questions about like these agents. Like, okay, how lethal do you need it to be, right? So just to be reasonable. So we don't work on chemical weapons anymore, but the Russians used them because for a time we didn't know what they were. They'd never been used, but through urinalysis and looking at metabolites, things like that, you can identify the compounds. In 2017, the brother of North Korean leader Kim Jong-un had VX thrown in his face in 2017. What happened was two different women, one with each vial of the binary agent, threw it in this person's face, right? So the chemical then combined on the face to make the chemical agent and formed VX, and that person died. Another recent one was Alexei Navalny, deceased Russian opposition leader. He was poisoned with a Novichok chemical. He actually survived. This is him surviving. But then he was eventually went back to Russia, and he died in a concentration camp in Russia. So there's a lot of chemicals out there that are pretty toxic, and they're not chemical weapons. So what about other agents? So chlorine gas is one of them. Chlorine's produced in large quantities, and it's used in industry. So what about if terrorists get their hands on some other chemicals that they don't have to be as toxic as chemical weapons, but they still could be very dangerous because they're way more accessible. And they're, because of that, they might be used in a terrorist attack. So we call those TICs and TIMs, toxic industrial chemicals and toxic industrial materials. So some of the common ones are here, just to show you their lethal doses. So sarin is lethal at 36 parts per million. Hydrogen cyanide, very common chemical used in industry, 120 parts per million. There's chlorine in there, but you also have hydrogen chloride or hydrochloric acid, carbon monoxide, ammonia. These things are like commonly transported by train or whatever else. So you can imagine a chemical attack. In fact, at the Coast Guard Academy, we mimic what would happen if a chlorine tanker coming through the train track on campus. Who would be safe? How would we make sure they're safe? Would they be exposed to the right chemical? Would they be able to, would it be a possible attack on our base, for example? So another modern issues I want to mention is fentanyl a chemical weapon? So I like reading this. There's a person named Al Moroni. He's a really fascinating blogger. He used to work for the government. I agree. I'm saying this right now. I do not agree necessarily with his opinions, and so full disclosure, I'm not saying I agree with him, but he writes interesting things. He argues that fentanyl is not a WMD because if you classify it as WMD, it causes all these problems for how it would be regulated and such like that. Fentanyl is a problem, and we do worry about it. So one of the things you worry about is, as a law enforcement officer, you go up and you find somebody exposed to fentanyl. they're carrying large quantities of it, you can die from exposure. Certainly you can. So that's an issue there. All right. The final part of the talk I want to mention is the strategic national stockpile. So what are we doing to protect ourselves from these chemical weapons? From a public health perspective, how are we making sure we're safe? And how are we protecting not just military people, but also civilians? So about 5 years ago, I wrote this article with a former student of mine, and we looked at what the strategic national stockpile has done. So since 2001, the anthrax letters of that time, that revealed a lack of preparedness for terrorist attacks on civilians. We realized that under President Bush, that happened right after 9/11. These anthrax letters happened, and people were like, wow, we have no way to treat Americans, civilians especially, if there's a large scale attack. And so we need to develop medical countermeasures that can be given to people post exposure. That's the key. Soldiers, you can give preventatively. You can prophylactically treat them. You know they're going to be exposed. They're going out to fight a chemical weapon. You're going to give them a chem pack. But what about civilians who unknowingly get exposed? And then all of a sudden you have to treat them. So for about 4 years now, there's a program to develop medical countermeasures that can be given to people post-exposure so that they can survive chemical or biological exposures. And so now this is only for medical treatment. And so just to give you an example, 90% of the US population lives within about an hour of a chem pack, which is an antidote to nerve agent, enough to treat 1,000 patients. So if an event were to happen in the US, this SNS would be called to task. They would deliver the chem pack and hopefully they would treat civilians with this chemical. Basically, it's an auto injector and it treats you with atropine and some other drugs that will neutralize the nerve agent, or actually not neutralize it really, but restore your acetylcholinesterase through a mechanism I won't get into. But a lot of other therapies have been invented since then. Because of this, we now have anthrax vaccine. We've realized at this point in time, 2001, we had a lot of really old vials of smallpox vaccine. Vaccination for smallpox stopped in the 1980s. So the idea was, well, we need to make more smallpox vaccine, and then there needed to be medical counters made for all these other things as well. So ionizing radiation as well, other things like that. So the considerations for this are problematic because how are you going to convince a drug company to make a drug that's going to treat an agent that no one's going to buy because no one's going to ever be exposed? So the US government basically has to make the market. They have to buy enough drugs of these, if they get invented, that will make the companies want to do this. So they have to negotiate the price, say, yes, we want you to make this smallpox medicine, and if you make it and it works, we will buy 3 million doses and we're going to pay you this price and we're going to store it, right? So if you don't do it that way, the only alternative is for the government to make them themselves. And most Americans don't think the government's going to be a good drug company, right? They're not, maybe not the best. So getting the private sector to do this is probably the smartest idea. So one of the problems, though, is the more drugs you add to the stockpile, what happens to drugs? They expire. So the maintenance costs rise over time. So over time, more and more the budget goes toward maintenance and less to development. But let me tell you the wins. So 2017, Project BioShield funds 2 vaccines and 2 treatments for Ebola. There's a Merck single-dose vaccine, a prime boost vaccine regimen from J&J, and 2 different monoclonal antibodies. There are 1.13 million vaccine regimens in our strategic national stockpile. Should Ebola get into the US, you can vaccinate 1 million people. Why not 350 million people? Because Ebola is not terribly transmissive, right? You have to be in physical contact with somebody with Ebola. You have to touch them to get it. It's not spread by aerosol. So these are all been supported by the government. They got FDA approved and they're in the stockpile ready to work. And in fact, we've had a couple patients treated with these, and these same medicines have been used to help quell the infections in Africa. So this is a win. Another win was Mpox. So following 2001, we basically approved 2 new smallpox vaccines and 2 drugs to treat smallpox. Smallpox is weird because it's one of the only vaccines that can be given post-exposure, post-infection, and it works. You can give, if someone's thought to have been exposed to smallpox, you can treat them, give them a shot the next day. They will be protected against that smallpox infection. So they figured out that smallpox vaccine actually works against Mpox. And there was a vaccination campaign to vaccinate the people most at risk, which happened to be people who participated of same-sex, you know what I mean. So, but these drugs worked against Mpox, and that also was a good win. It basically helped quash that the Mpox outbreak that happened. So that's also a big win. So those are just two. In the SNS history, another couple things that have happened, of course, was the technology used to make the COVID vaccines, the mRNA vaccine, that was supported through a lot of grant support through the U.S. government for a large number of years and was very successful. So and might maybe used again in the future. So Zika, other things like that. Now, over time, the SNS has drifted from being solely about bioterrorism to also being about pandemic response. I will point out that the Strategic National Stockpile was not designed to have enough PPE for every state in the entire country for over a year. Like, that's impossible. So that's why we ran out of stuff in COVID. It's meant to handle small outbreaks, not nationwide permanent, shutdown of things. So we could do that. It would just be very expensive. So this is a list also produced by their website of all the things that they've helped with. So COVID-19, Mpox, and now the H5N1 bird flu as well. So it's kind of taken on another mission. So I'll just conclude tonight by saying we are in a much better place than we were in 2001 with regard to protection against biological, chemical, and radiological threats. The course I teach for University of Maryland, we basically review all of the products in development every semester for different agents. So I'll pull 3 new smallpox vaccine, drug, or biologics that are being worked on, being supported by the government. And we look at those and we say, oh, which of those are going to be approved? And I've started reading about tecovirimat, which is TPOXX, the inhibitor for smallpox, before it was even approved. And it was very exciting to see stuff like that get approved and go to protect us. And if you think about the cost of these protective measures versus the cost of public health, it's really small. We're looking at, compared to the price of a jet fighter or an aircraft carrier, right? Those things, having these protections in place for these things also make other nations not want to use them against us. They know that we have protections there. They're not going to try, right? So, of course, there's fears of what about synthetic biology and producing new agents that haven't ever existed before. Yes, those remain a threat. So we do also need a capability to produce rapid new vaccines very, very quickly in the event of something happening bad. Producing drugs is much harder. Vaccines are much easier to produce. As we saw with COVID, I think we're actually in a much better place. So so I'll end there. So I hope that gives you a little bit of a positive outcome from this talk, that things are better off than they had been 20 years ago, but we're moving in the right direction. So thanks again. And anybody have any questions?
Thank you. That was fascinating.
Oh, my speaker went off. Hold on.
Oh.
I didn't even notice. If you were asking me questions in between, I'm sorry, I didn't hear anything.
No, I didn't. I didn't hear any. Chelsea, you didn't ask anything during the talk, did you?
Oh, I don't know.
No.
Yeah.
Okay.
So
One quick question.
Yeah,
One quick question I did want to ask. You had talked about your background a little bit at the beginning. Is there any, for people who are interested in this sort of field, either from like a lab science perspective or more policy, do you have any advice that you could give someone, or if you could go back and give yourself advice when you were starting this pathway? Any advice, thoughts, anything like that you could offer?
Yeah, so when I worked on this, I was working on the side of we were an academic lab. We were looking at my boss before that had been working mostly on oxidative stress. I think he kind of fell into this. When the government put out this grant program to work on these therapies, it was a lot of money. He ended up getting $20 million to support 5 different investigators to help work on this. It was kind of like a crash project in that sense. But yeah, it's a great question. A lot of this work is done by the government, but not really sure where we're at with that at the moment, in terms of um, what career paths to go in to support this kind of thing. But what I will say is there is a lot of state agencies and when you so I have that co-author of mine, Chandra. She actually works for New Jersey Department of Transportation, and like when they're doing a big event at a stadium, one of the considerations is how we protect from a bioterrorism attack here. They worry about those things. They are talked about. So I think that emergency response side of it is probably like one of the most interesting side, especially if you're not going to be in the lab doing science work on it. I think that emergency response is the way to go for that. And I don't have a lot of insight on how to get into that career path, but you might have better than me. So, but,
One thing I did want to, like a jumping point from that. I know a number of people look at not having a clearance as a hindrance, or look at jobs that will get them a clearance because they think that that's really important. I know you and I have had the conversation before that you don't have one and you think that that's a benefit. So can you talk about that a little bit?
well, yes, because well, especially as a teacher, and whatever I can find on the internet is fair game, right? So, but if you have a secret clearance, there are things that you're expected to you're not allowed to talk about anything that's considered secret, even if it is out there. So that makes it very difficult for you. I remember when I would talk to my friend who was a reserve colonel in the army who worked in chemical weapons. I would ask him a question that was near that line. He would always pause and he would think, how can I answer this? It just slows you down quite a bit, right? To be able to have a frank conversation with someone who doesn't have a clearance about it. And for me, the perspective of teaching students who don't have clearances yet,
Mm-hmm.
it's just more valuable to me to not have the clearance at the particular time. But there definitely is a place to have that. I mean, when you're talking about so the other place would be, when DITRA or BARDA puts out a grant program. BARDA is the authority that basically helps get drugs closer to market approval for these things. They provide support for the clinical trials because no one else will, right? They provide support for the clinical trials for the very most promising drugs. You might ask the question, well, if they want to work on this particular agent, why aren't they just telling us that? Well, that information is it is a secret information. So as a civilian applying to a grant program, you don't know what they care about most. You can have a hint about it, but you really don't know until the funding happens. And then you say, oh, okay, they must care about this one, or they must not care about this one because I've applied 3 times and it never gets funded. So that's my friend who works on seizure inducing agents. I didn't talk about them, but those are important. And also another one is the same things that are in rat poison that causes you to bleed. They prevent their blood clotting inhibitors. So those are actually ones that I know about that are being looked at as potential chemical weapons as well. Although for those, your route of exposure is difficult. Like you'd have to contaminate food or water or something like that. It's the breathing ones that are the really big issue for that. So you can kind of guess that because, we have these water treatment plants. People are always like, oh, well, they're going to spike our water with cholera and that's going to infect New York City. Well, guess what? New York City's water system is designed to remove cholera. Like it literally, the chlorine will prevent that from happening entirely. So I drifted a little bit in the answer, but that's my rationale for security clearance purposes. I mean, I think it is that depending on the job you'd want to do, it is valuable.
Yes, definitely. I think it's interesting that you were able to highlight where like opportunities where it would not be, because I know that some students get frustrated, like, oh, I want to get into this field and I don't have one. So it's not the end all be all. There are opportunities outside of that.
Exactly.
Chelsea, did you have any questions?
I did actually, Dr. Gray.
Go for
Thank
it.
you so much. Great talk. My major question was, what do you think is the biggest chemical threat to the US? And is there a way that you're able to screen for it?
Yeah, I mean, I think nerve agent remains, right? Because even with atropine and the auto injectors and there's drugs that reactivate acetylcholinesterase, the real big problem is your window of treatment time is so short, like it's minutes, that even with a chem pack available in an hour, it's like, well, the people who are exposed first are going to die. Mustard gas, you're not going to die from that. You might end up with a horrible injury, but those people are going to be able to be treated. Nerve agent remains, I think, even to this day, one of the most serious. So the Novichok is in there, right? The Novichok is one of the chemicals. They're also nerve agents, and I think that's the one that would keep people up at night. You can't expect the civilian population to be wearing gas masks or have them even, or have a full suit. It's just not going to happen. From a Coast Guard perspective, I worry about it because Navy ships, some of them have positive pressure, so they actually filter the air coming in, and they have positive pressure so that no, if you were to hit a Navy ship with a gaseous weapon, it would not get into the ship, right? Not so much for Coast Guards. So we worry about that a little bit. But that said, there's still like a limited ability to actually cause harm in the sense that once you're aware of that situation, you might take really dramatic response, right? The first ship that gets attacked, boy, after that, there's going to be massive retaliation, maybe even nuclear. So that's kind of the response there. So if you go back to Nixon and you ask, why did you remove our chemical weapons program? Nixon actually stopped it. And it's because we have nuclear weapons. He argued we didn't need them. So, and having them was a liability. So that remains the one we care most about.
Gotcha. So it's a risk benefit sort of situation.
Yeah, and it's because even if you can envision the best possible treatment for nerve agent, you still have the issue of delivering it within minutes. So unless you're going to give people auto injectors and they're walking around with them, which I just can't even imagine, right? That you hit something like a stadium, it's there's going to be mass casualties. So that's what I worry about. I don't know how you can fix that. So there is detection methods for that, but I don't really cover that a lot, but they're not foolproof. So
Thank you.
Great answer, but you need to add something to that just so that way we don't close on that note.
go ahead.
Okay, so yes, everything he just said is true, but luckily we have really smart people like Dr. Josh Gray working on this, so that way we don't have to worry about those things as much as we would if we didn't have him. So
That's true.
Yay.
It's true. And we have to be, like Jen's office helps helps train people to use the gear when they need it. So I think the other thing you think about too is, man, if it were that easy, wouldn't it be happening more often? So I think post 9/11 with the anthrax letters, we all were waiting for the other shoe to drop with more things to happen. And they just never have in 22, 23 years. Not for lack of effort. Some people have tried ricin here and there, but no mass casualty attempts of significance. There's been, I can go through a whole bunch of little stories about them, but I think the biggest exception might be the Tokyo subway incident where they released nerve agent inside of a train, and that was a very significant incident. But again, it was um, a one of a kind event, so I'm thankful for that.
definitely. So I want to be respectful of everyone's time. Josh, thank you so much for your time tonight. This was really great. This was fascinating. I really enjoyed it. And this did not happen because I planned this. This was just the way schedules worked out. But next month we are also going to have a speaker talk about chemical weapons from the perspective of riot control agents and the CWC. So it'll be a nice follow-on to what we talked about tonight. So that is going to be the first Wednesday of December, which might be the 4th. It's actually the 3rd, so December 3rd at 8 o'clock. So you will see the invite for that going out soon. But Josh, thank you so much for your time tonight. We really appreciate it. And I look forward to getting up to the Academy soon and seeing you.
All right. Thank you. Nice talking to you, Jen. Nice to meet you, Chelsea. And
Thank you.
See you later.
Thank you. Have a great night.
You too. Bye.
Bye-bye.